Hello, honors algebra students. Mr. Lawrence here, and we're going to be doing lots of quadratic application word problems today. It's a testing day, and you're watching this video, and there'll be a worksheet attached in Google Classroom, and you'll need to do those problems over the weekend. All right, here we go. Now we're going to use this equation, h equals negative 16t squared plus or minus v sub o t plus s. And remember that this is for feet per second. If we're dealing in meters per second, this would be a different coefficient. A would be negative 4 9/10. So remember that h here is the ending height, right? This is the ending height. The v sub o is your initial velocity, right? Initial velocity or original velocity. T is time in seconds. Time in seconds. Time in seconds. And then S is your starting height. Okay, pardon me, I feel a sneeze coming, huh? Oh, sorry about that. Hopefully, at least I got to warn you that time. By the way, there's another one coming. Ooh. All right, can't quite shake this cold. All right, so let's see a couple of problems here. It says a rocket is launched off the ground with an initial velocity of 120 feet per second. Determine how high the rocket will travel. How long will the rocket take to get to its maximum height? When will the rocket be 30 feet off the ground? And when will the rocket, oop, that says ball, silly Mr. Lawrence. It's a rocket. When will the rocket hit the ground? Okay, so first thing I'm going to do is I'm going to draw a picture because I'm so good at art. Guess what that is? That's the ground. Okay, and now I need my rocket. Kind of pointed like that. Maybe a little fin action going on here. All right. And the rocket is going to travel on a path something like this, right? Now, the first question is, how high will the rocket go? Well, I'm looking for part of the vertex, right? If I put some axes in here, like a y-axis and an x-axis, right? I am looking, I'm sorry, if I labeled these, this would be the time, right? And that's in seconds, and this would be the height in feet off the ground. Well, the vertex is going to be the highest point, so I'm going to be looking for the y-coordinate of the vertex, right? I'm going to have a t-coordinate and an h-coordinate. I'm looking for the h-coordinate of the vertex. But question B says, how long will it take to reach the maximum height? Well, that's going to be the t-coordinate. So you see, I'm going to find the vertex and use its parts to answer the first two questions. So my equation is h equals negative 16 t squared. It's going to be plus because the rocket's being launched upward against gravity and the initial velocity is 120 feet per second. So I'm going to put 120 there with a t, and the starting height is the ground, so it's going to be 0. Now, the ending height is going to also be 0 because the rocket will return back to the ground. So I'm going to make that a 0. Now, I can go quadratic equation on this, although this is an interesting one because I might be able to factor it. I might be able to solve by factoring. Tell you what, this one I'll solve by factoring. The other one I'll do by using the quadratic formula. So I'm going to see if I can find the greatest common factor of 16 and 120. All right. And let's see, 4 is going in 4 times. All right, I don't know if 16 is going to go in to 120 evenly. I suspect it's not. 8's easy to tell. If I cut 120 in half, I can turn it into 60. If I cut 60 in half, I can turn it into 30. And if I got 30 and a half, I turn it into 15. I know 8's going in to 160. Why? Because I divided by 2. I divided by 2, and I divided by 2, which is the same as dividing by 8. So I'm going to go ahead and pull the 8 out, an 8t as a matter of fact, and I'll actually pull out a negative 8t so that my 8 coefficient becomes positive. And then I'll be left with a 2t, and that'll be a minus 15, I believe. And yeah, I did get the GCF because there is no common factor other than 1 left on the quantity inside there. All right, so this is going to tell me, actually I said I was going to do parts A and B first, but I'm not doing parts A and B. If I solve both of these for 0, negative 8t equals 0, and I divide by negative 8 and divide by negative 8, I get t equals 0. All right, and then if I solve 2t minus 15 for when it equals 0, I'll get 2t equals 15, and then t will equal 7.5. So right here is when t equals 0. And right here is when t equals 7.5 seconds. So I actually can come up here and say the ball will hit the ground in 7.5 seconds. All right, so that part was pretty cool. I actually didn't intend to do D, but I got kind of sidetracked and it was pretty cool. So let's go back and do A and B. Let's go find that vertex. So to find the vertex, the x-coordinate of the vertex, or in this case, the t-coordinate of the vertex, I'm going to do negative b over 2a. So t is going to equal negative b over 2a. And the equation before I factored it, b was 120. So I'm going to have negative 120 over 2a, and a is negative 16, so that'll be 2 times negative 16. And so t will equal a positive, and I'm not going to multiply these, I'm going to do some simplifying. I know 2 is going to go into 120 60 times, and then 4 can go into here 4 times, and go into there 15 times, and it looks like t is 15/4. All right, or 3 3/4 seconds. Now, by the way, 15/4 is half of 15 halves, isn't it? Right? And 15 halves is the same as 7.5. Half of 7.5 is 3 3/4, isn't it? Yeah, so I'm really liking the fact that I got the halfway point. Now, by the way, that will only be true when the rocket is being launched off the ground. So I know the answer to B. It will take 3 3/4 seconds to reach the maximum height. All right, so to find the actual maximum height, how high it goes, I'm going to have to take h equal to negative 16, and that looks terrible. Let me rewrite that. So h equals negative 16, and I think I'm going to leave the fraction here. What was it? 15/4? Yeah, you'll see why in a second. 15/4, and I'm going to square it, plus 120 times 15/4. Okay, so when I do this, I'll have a 16/1. Another sneeze coming on, by the way. Sorry about that. Times 225 over 16. Oops, I lost my negative. There we go. plus 120 over 1 times 15 over 4. So I can do some canceling, and I'm going to get h equals negative 225 plus 4 is going into there 30 times. I think that's going to be 450, right? And so if I have 450 minus 225, well, that looks like it's going to be 225 feet off the ground. Yeah, so h is going to equal 225 feet. So it's pretty easy. 225 feet. That's off the ground. All right, now C is really cool because I want to know when it will be 30 feet off the ground. So in other words, I want to know when it will be here, but also over here. Yeah, because it's going to be 30 feet off the ground twice, isn't it? It's going to pass 30 feet off the ground on its way up and then back on its way down. So watch this. This is really cool. What I do is I pretend in my formula, I know that h equals negative 16 t squared plus 120 t. And I know the starting height is 0. I pretend my ending height is 30. Yeah. And when I solve this quadratic trinomial, it's going to be in a minute, it will provide two solutions, and they will be the 2 times of when it's 30 feet off the ground. Now, to solve the quadratic, I want it equal to 0. So I'm going to subtract 30 from both sides. Right? And so my new equation, or my equation, starts to look like this. T squared plus 120 t minus 30. All right, and now on this one, I'm going to do the quadratic formula. It might factor, but it might not. So I'm going to do the quadratic formula. So A, B, C. Easy as negative 16, 120, negative 30. Whoa, what the heck is that number? It's supposed to be a negative 30. Let me rewrite that. All right. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So there's the setup for my formula. So now I'm going to get x equals negative 120 plus or minus the square root. And what am I going to get under there? Well, 12 times 12 is 144, but there's 2 zeros for 120 times 120. Minus, because there's 3 negatives, let me see, 16 doubled, 32 doubled again is 64, 64 tripled, it's be 192 and a 0. So minus 1,920. All right, and that's all going to be divided by a negative 32, right? 2a, negative 32. Okay, at this point, I'm going to go to my calculator. And I've simplified it. I don't think they're going to come out to be very pretty answers. So, hold on. My calculator's a bit of a memory hog. It's going to load up for me here. All right. So, I am going to start a quantity, and I need the negative of 120, negative 120, plus the square root of 14,400 minus 1,920. Move out of there, close the quantity, and divide by negative 32. And there we go. So there's the first time. So in about 26 hundredths of a second, 0.26 seconds approximately. And to get the other time, I'm just going to come up here, edit this equation, and change this. Where'd you go? Oop, I must have pressed it too many times. Look at it stacking those commands. Stop blinking. Change that to a minus sign. And this will be the other time. So about 7 and 24 hundredths of a second. Now a cool thing is, look at that, if I add those together, here, hold on a second, let me write down the two answers I got. So I got, oops, where'd it go? Let me in pen mode. I got t equals 0 and 26 hundredths, rounded, and I also got 7 and 24 hundredths seconds. Now, I just kind of happened to notice something there. It's supposed to take 7.5 seconds total, and what happens if I add those two together? I just happen to notice I got 7.5 seconds. I'm going to pay attention to that, see if that happens again. So, anyway, there are the two times. So, it'll be at 0 and 26 hundredths seconds and at 7 and 24 hundredths seconds. Okay? All right. I'm going to give you another problem here. And you can go ahead and try this one. Now, I will suggest to you that this is being thrown downward, so the initial velocity is going to be negative. And this, oh, no, that's not a velocity. I'm sorry, it's 100 feet off the ground. Okay, the initial velocity is 25 feet per second, and that's where the negative is. All right, so when will the ball be 50 feet off the ground? And when will the ball hit the ground? All right, well, go ahead and see if you can solve it. Pause the video. Here comes my solution. So I've got this guy up on the roof here, right? And when he throws the ball down, it starts at 100 feet off the ground, right? The ball's going to kind of go like this. So h is going to equal negative 16 t squared minus 25 feet times t, and the starting height is 100. Okay. Yeah, there we go. Okay, so when will the ball be 50 feet off the ground? I make h 50, negative 16 t squared minus 25t plus 100, and that turns out to be negative 16 t squared minus 25t plus 50. And so now I can go to the quadratic formula, right? And so I'll identify A, B, C. Easy as negative 16, negative 25, 50. And I go to my quadratic formula. And I guess I shouldn't be using x on this, but it's the same thing. I can put t, right? And so t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, excuse me. So t is going to equal 25 plus or minus square root of 625 plus 32 times 5. Let's see. 32 times 5 is going to be, carry the 160, so 1,600, I think. All right, and if I add those two together, 1,600 and 625, looks like I'm going to get 2225, right? So I'm going to change that to 2,225 under my square root. Remember, that's the discriminant. So 225, and that'll all be over negative 32. All right, so I'm going to get 2 times here. And I'm not going to do this one on the calculator, you can see, but I'm going to do it on a handheld. So I'm going to have 25 plus the square root of 2,225. I think I wrote that down wrong in there. Sorry about that. Yeah, I get that extra 2 in there. And then I'm going to divide that all by negative 32. And I got a negative time. So I'm going to ignore that one. I'm going to be interested in the positive time. So I'm going to change it to 25 minus. And when I do that, it's going to be about, t is going to be approximately, approximately 0 and 69 seconds. All right, that's it for the video. Showed you a couple different types of problems. We'll have you get started on the story problems, the application problems on the worksheet. All right, you have a good weekend. We'll see you Monday.